In this lecture, we'll understand the pressure measurement devices. So there are three types of devices are there, that is barometer, manometer and mechanical gauge. So barometer which measure the atmospheric pressure, and manometer are there and mechanical gauge are there. So let's write the types of devices. So types of devices, there is a three types of device. One is barometer, another is manometer, and another is mechanical gauge. So barometer will be like this. So here barometer is basically measure the atmospheric pressure. So this is the mercury. Here there is a mercury and there is one mercury tube is there. Okay, and so here up till this there is a mercury. This is the mercury column height. So this is the mercury column height. Okay, so here inside that there is a mercury, and here the height, that is h, and here there is a this zone, there is a vacuum zone. Okay, vacuum zone, and vacuum zone means P tends to 0, and this is high density fluid and very low vapor pressure. So this is high density fluid and very low vapor pressure. Okay, so in previous lecture we see that the vapor pressure of mercury, that is very low, less, that is almost equal to 0.17 kilopascal at 20 degrees Celsius temperature. Okay, so this is all about the barometer. Barometer was first invented by Torricelli. Okay, so there are four types of mechanical gauge are there. One is Bourdon tube pressure gauge. So there is a four type of mechanical gauge. One is Bourdon type pressure gauge, pressure gauge. Okay, second, that is the diaphragm pressure gauge. Third is bellows pressure gauge, and fourth is dead weight pressure gauge. So dead weight pressure gauge. There is a four type of mechanical gauges are there. There is Bourdon tube pressure gauge, diaphragm pressure gauge, bellows pressure gauge, and dead weight pressure gauge. Okay, so let's focus on the manometer. Okay, this is very, very important. So manometer, so the manometer, the pressure measurement is defined by liquid column deflection. So here the pressure measurement is defined by liquid column deflection. liquid column deflection. Okay, so the manometer are also two types, that is simple manometer and differential manometer. So manometer are two types. One is simple manometer, simple manometer, and another is the differential manometer. Differential manometer. So simple manometer is also so simple manometer measure the pressure at a point. Okay, so it measure pressure at a point, and it is also three types, that is piezometer, U-tube manometer, and single column manometer. So this is also three types. So this is also three types. One is piezometer, that is second one is U-tube manometer, U-tube manometer, and third one, that is single column manometer. And differential manometer are also three types. So differential manometer is also three types. One is U-tube differential manometer, one is U-tube differential manometer, U-tube differential manometer, U-tube differential manometer, inverted U-tube manometer. Second one, that is the inverted U-tube manometer, U-tube manometer, and third one, micro manometer, micro manometer. So simple manometer is measure the pressure at a point. So it measure the pressure at a point, and the differential manometer measure the pressure difference between any 2 points. The pressure difference between any 2 points. Okay, the pressure difference between any 2 points. Now let's focus on the piezometer. Okay, so piezometer is the simplest form of manometer whose one end is open to atmosphere and other end is are connected where the pressure is to measure. So it measures the gauge head. Okay, it measures the gauge head. Let's focus on that. The piezometer, the topic name, that is piezometer. Piezometer. So it is the simplest. So here the piezometer will be like this. Suppose if you want to measure the pressure of one pipeline, okay, if you want to measure the pressure, so here you want to measure the pressure at that pipeline. So okay, so just there is a single column is there, and the liquid deflection consider that is the height. After that there is a liquid deflected. Okay, so there is a fluid inside that. So this is the pipeline here. Okay, so if so here this is, suppose this is the reference line. So this is the reference line here. So this is the reference line. This is the reference line. This is the reference line, Okay, and this from here to here the height is, so here from this point to this point the height is z. So this is, so this is z. Okay, z is the height from the reference line to this point, and here to here the, this is known as, so h, that is equal to p by omega. Okay, so the total height, so if you want to calculate the total height that is equal to p by rho g plus z plus v square by 2g. So we know that the pressure head, that is total head, that is p by omega plus z plus v square by 2g. So this is the total head, and if you want to calculate the piezometric head, to piezometric head, for that case z plus h, so z plus, so p by rho g plus z. So here the piezometric head that is equal to p by omega plus z. So this is the piezometric head. Okay, this is the piezometric head. Now you can also attach one tube to measure the pressure in this way. So you can attach the tube here also. Okay, so any orientation you can attach this tube. Okay, so here there is another tube. You can also attach here also. The liquid level deflection will be the same. So this is the manometric fluid deflection. Okay, so here the z is, the height is z, so there, here is the z is, this is the z, and here to here the distance is h, that is equal to p by omega. Okay, so you can also attach one tube here also to measure the same pressure. Okay, so to measure the same pressure you can attach here also one tube. Okay, so here there is a z, so here to here the distance is z, and so there is a same level, liquid level deflection is there. So the height, this level is same. Okay, and this height, that is h, that is equal to p by omega. Okay, so let's write the definition of that. So it is the simplest form of manometer. So what is piezometer? So it is the simplest form of manometer whose one end is open to atmosphere and other end are connected where pressure is to measure. Okay, So it measure the gauge head. So it measure gauge head. Okay. So, but here the disadvantages is that it cannot measure the gaseous pressure and it cannot measure the pressure which is less than atmospheric pressure. So it is difficult to measure the high pressure of low density fluid due to large liquid column deflection. Okay, so these are the advantages of the piezometer. Okay, so uh, so here we see that the piezometer can be installed in any orientation because the piezometric head P by omega plus Z is same over entire cross section in the pipe flow. So here the piezometric head here P by omega plus Z, this is same for any orientation. For this orientation so P by omega plus Z is same. For this orientation P by omega plus Z, that is also same. For this orientation P by omega plus Z, that is also same. So piezometer can be installed in any orientation because the piezometric head P by omega plus Z is same over entire cross section in pipe flow. So let's write. So here the piezometer can be installed. The piezometer can be installed in any orientation because the piezometric head because the piezometric head, what is that? That is P by omega plus Z. Z is same over entire cross section. Is same over entire cross section in the pipe flow. Of the pipe flow. Okay. Okay, so what is the disadvantage? So the disadvantage is that so the disadvantages are that it cannot measure the gaseous pressure. So first disadvantage, cannot measure the gaseous pressure. Second, it cannot measure the pressure less than atmosphere. Cannot measure the pressure less than atmosphere. And third, it is difficult to measure the high pressure of low density. So it is difficult to measure high pressure of low density, high pressure of low density fluid, due to large liquid column deflection. Large liquid column deflection. Okay, so consider this is one pipeline is there and you want to connect here. So there is a pressure P at a point So you connect one piezometer and the liquid column deflection. So this is the here is the liquid column deflection is there. Okay, so there is a liquid. Okay, so here this is the reference line, this is the reference line, and here to here the distance is z, distance is z. Okay, and this is the here to here the distance is h, that is p by omega. Okay, and here there is a atmospheric pressure, so here there is a atmospheric pressure. Okay, so if you want to calculate the absolute pressure, P, if you go upward direction, that means vertical upward direction, so minus rho g h, that is equal to here the P atmospheric pressure. So from here gauge pressure, that is equal to P atmospheric pressure. So this is the absolute pressure, so this is the P atmospheric pressure plus rho g h. So this is very very important. So here the P is the absolute pressure, so this is the absolute pressure, so P is the absolute pressure. So P is the absolute pressure, P atm is the atmospheric pressure, and rho g h is the gauge pressure. So if you consider that the atmospheric pressure P atm that is equal to 0, then the gauge pressure will be that is equal to rho g h. Okay, so the gauge pressure will be rho g into h. So here the atmospheric pressure that is equal to 0, so P equal to rho g h, so this P will be the gauge pressure. Okay, so this P will be the gauge pressure. Okay, now there are another concept. So suppose so first draw this draw the diagram here. So here there is a liquid level, so up till this there is a liquid level. Okay, the liquid is in static condition, suppose. Okay, and this is the reference line here, this is the reference line. Okay, and if you install one piezometer, so this is the piezometer. Okay, so here there is a liquid deflection are there, so this is the piezometer, and up till this there is a liquid deflection is there. Okay, so this is the liquid deflection. So here this is the piezometer, so this is the piezometer tube, so this is the piezometer tube. And here this is the pitot tube. Okay, pitot tube. Okay, so here this height, so here to here for piezometer, here to here the height is z, and here to here the height is p by, so h that is equal to p by omega. Okay, h that is equal to p by omega. Now So here this is the height, that is P by omega, but if you install pitot tube, due to that stagnation V equal to 0, stagnation point, okay, so there is stagnation point here. Due to that the liquid column depletion, the liquid level rises compared to the piezometer tube. So so there, up till this, the liquid column, the liquid height increases. Okay, okay, so here so here to here the distance is z, this is z, and here to here we see that the distance is h, that is equal to P by omega. Okay, so what is that? Here to here the distance, what is this? That is V square by 2g. Okay, so V square by 2g, so this is the, consider this is h. Okay, the liquid column deflection, extra liquid column deflection for pitot tube, that is considered h. Okay, so now from here you can write h, that is equal to V square by 2g. So h, that is equal to V square by 2g. So from here you can calculate V, that is equal to under root 2g h. So if you want to calculate the velocity at this section, so if you install a pitot tube, so from this equation you can calculate the velocity. Okay, so this is important one, just remember this thing. Okay, so here so consider here the liquid level is same, means constant. Okay, and the liquid flowing in this way. Okay, so the liquid flowing in this way. Okay, so this is all about the things. This is all about the manometer, means piezometer. Okay, so in description I uploaded my handwritten notes. You can see the same things also. Like, share, subscribe my YouTube channel. Thank you.